Tonight's homework assignment comes from page 291, and today we started talking about functions. On numbers 6 through the bottom of the page, it's asking for us to determine whether each relation is a function. We said today in class that with a function, each x value or each part of the domain can be paired with exactly one y value. So if we see an x that is paired up with more than one y value, then it is not a function. So if we look at number 6, our members of the x or of the domain are listed here on the left, 6, 5, and 2. It looks like there's only one arrow coming from 6 across to the other side. That means that that 6 is only paired with 3. 5, it looks like only one line is coming from 5, so 5 is only paired with -2. And 2 is only paired with 3, so 6 is only used once, 5 is only used once, 2 is only used once, so 6 is going to be a function. When we look at number 7, we need to analyze the x values. Well, we have a -2, +5, +5, +4. So since 5 is paired up with 3, but 5 is also paired up with 4, that means that number 7 is not a function. Again, if the x is paired up with 2 different y values, then we know that our graph is not a function. All right, when we are given a graph to determine whether or not a relation is a function, what we can do is to use the vertical line test. We said in class that means that we can draw a vertical line, or we can use our pencil, and we can move that pencil across the page. Well, as we move the pencil across the page, does it touch any part of the graph or any ordered pairs, any two ordered pairs, or any two spots at the same time? Well, on number 8, we can see that while we're here, it's only touching that bottom point. As we move it across, now it's touching another point, but at any given time, it's only touching one dot at a time, or one ordered pair at a time. So that means that number 8 is a function. So we would say that it is a function. 9 and 10, we are now, instead of being given a table or a graph or a mapping diagram like this, we have just a relation written out for us. So again, we need to analyze the x values and just look and see if any of them are being repeated. Well, we have -3, -1, +1, +3. None of the x's repeat, so number 9 is a function. We would do the same thing on number 10. The next section that we're looking at is 14, 15, and 16, and 17. Number 14, it says, which of the following graphs represents a function? Again, now that we have graphs given to us, what we can do is use the vertical line test. Vertical line test says that we can draw a line going straight up and down, and we can move that line across our graph and see if it touches any two parts of the graph at one time. So at every point in time, as we move that red line across on graph A, we're going to see that it's only touching that blue line in one place at all times. With that being said, we know that A is going to be a function. It's a function because it only touches one part of the graph at one time. When we look at graph B, though, we're going to see that at every point where our red line is touching the graph, the blue line, that red line is touching the blue line in two places. It's touching here and it's touching here. With that being said, graph B is not a function. B is not a function. And again, that's because at that point, the x values are the same all the way up and down that red line, but our y values are at two different places on that graph. If we do the same thing on C, we need to take that red line and shift it across the graph and see if it's touching two places at once. We're going to see that it doesn't. So C is also going to be a function. Down at the bottom, numbers 15 to 17, the directions say, or if it says, if h of x is equal to 3x plus 2, find each value. We say we're really just going to evaluate these like we've evaluated all other expressions in our lifetimes. But what we need to understand is that this number that is in parentheses, that says h of -4, that's asking what the value of this expression is when our x value or our domain is negative 4. So all we need to do for 15 is to think, instead of 3 times x plus 2, we're going to think 3 times negative 4 plus 2, and then we'll simplify that. That gives us negative 12 plus 2, which is negative 10. So 15 is going to be negative 10. On 16, we have 3 times x plus 2. So instead of the 3 times x plus 2, we can take the x out and we can put in whatever we have, h of 2 in this case. So 3 times 2 plus 2. If we simplify that, we'll get 6 plus 2, which is 8. And then h of w, well, we haven't seen one like this in class, but again, this just means that we're going to take out our x and put in w. So instead of 3 times x plus 2, we're going to have 3 times w plus 2. And that would be our answer, 3 times w plus 2. We can't simplify that anymore. So 15, 16, and 17 are worked out there for you. On the next page, we're doing the same thing. Determine whether each relation is a function. Well, we need to analyze the a's. In this case, we have a's and b's instead of x's and y's. Analyze the a's and see if any of those a's repeat. We see that we have negative 3, negative 2, 0, 2, and 4. So since none of these repeat, then we know that number 19 is a function. Let's look at number 20 is similar to number 19, so we'll skip over that, but look at 21. We see that on 21, negative 3 is paired up with negative 2, negative 3 is paired up with 0, and negative 3 is paired up with positive 2. We also see that negative 10 is paired up with negative 1, and negative 10 is paired up with positive 1. So each of our members of the domain is paired up with more than one member of the range. That means that 21 is not a function. So in class we said that the x's can be paired up, or the y's can be paired up with more than one x, but the x's can't be paired up with more than one y. So here we see x's that are being paired up with more than one y. If we look at 22 though, this is a function. The reason it is a function, we see that 0 is paired up with 5 different x values, but none of the x values are being repeated. That means that we don't have more than one arrow coming from each x value. 23, we would use the vertical line test, and 24, we would use the vertical line test as well. The next section down, 35 to 42, what we're doing is similar to what we did on the bottom of the last page. It gives us 2 functions, function f and function g. What we need to do is evaluate that function for the values that it gives us in these problems. So looking at 35, it wants to know what f of negative 4 is. Again, this just tells us that we're going to take our x value out and put in negative 4. So instead of 4x plus 2 on 35, we're going to have 4 times negative 4 plus 2. When we simplify this, it gives us negative 16 plus 2, which equals negative 14. So f of negative 4 on number 35 is negative 14. If we do the same thing on 36, g of 4, all we need to do is to take x squared minus 2x, and we know that instead of x's, now we're going to put in 4. So 4 squared minus 2 times 4. Use order of operations, and we get 16 minus 2 times 4. We know we're going to multiply before we subtract, so 16 minus 8. When we simplify that, we get 8. All right, but then if we look at some of the other problems on that section, some of them are more complicated than those last two. Let's look at number 41. Well, on 41, now we have 3 times f of negative 2. So really the only difference here is that we're going to find the value of f of negative 2, and then whatever we get, we're going to multiply by 3. So we're going to take our function of our f, 4x plus 2, and we're going to take out, we're going to take out the x, and we're going to put in negative 2 for x. So instead of 4x plus 2, now we have 4 times negative 2 plus 2. And then whatever we get when we simplify that expression, we're going to multiply by 3. So we're going to handle everything inside the brackets first. So 4 times negative 2 is negative 8. Negative 8 plus 2, when we simplify that, is going to give us negative 6. and then we know that we still need to multiply by that 3 on the outside. So when we simplify that, we get negative 18. So we would say in that equation, or in that function, f of negative 2 is equal to negative 18. And then if we look on the next page, well, this is the last section that we're going to go over together. There were a couple of other problems farther on that you would want to look at, but you should be able to handle those on your own for tonight.